Chapter 13, problem 22. The gauge pressure in your car is 2.5 times 10 to the 5th newtons per square meter, which is a Pascal. At a temperature of 35 degrees C, drive it on the ferry boat, and temperature drops to minus 40. What is the pressure in the tire now? Okay. All right. So this one begins with PV equals nRT, right? And so we have, I'm going to rearrange this a little bit and go PV over T equals nR. We have two different times here. We have time 1, right? And we have later time 2. Nothing has happened in terms of how much gas, how much air we have. We didn't have a leak, right? We just had a change in temperature. So PV over T equals PV1, PV over T for the first instance equals PV over T for the second instance. And in fact, since the tire is essentially a container, the volumes cancel out, V1 equals V2, and so we're left with P1 over T1 equals P2 over T2, right? Now we know P1, we know T1, and we know T2. All right, so what is T1? T1, now, very important, in these equations where we have just T and not delta T, the units we need are Kelvin, right? So we need 35.0 plus 273.1 K, right? $35 plus 273.1 is 308. Just call it 308. 308 Kelvin. That's T1. And T2 is minus 40 plus 273 is 233 Kelvin. 233 Kelvin. And now that we have these in Kelvin, we can use this equation. All right, we can say P2 is P1 times T2 over T1. So this is 2.5 times 10 to the 5th newtons per square meter times T2, 233, divided by T1, 308. Okay, let's go calculate. 2.5, 10 to the 5th times 233 divided by 308 is 1.9 times 10 to the 5th. 1.9 to the 5th newtons per square meter, which is just a Pascal, right? All right, that's what we would get when we dropped to minus 40 degrees, 1.9 times 10 to the 5th pascals. That's it for problem 22.